Did you enjoy that? Good. Now let's get back to work. Cue long-ass intro.
He's here. I know he's here. That's him. I'm telling you, that's him. I know he's here.
Jordan! Am I the meanest? Am I the fitting Jordan? I can't hear you.
I am back. The Shogun is back on the scene, and the Shogun is the master. Why don't you sit down and shut up? Why don't I sit down and what? I said, why don't you sit down and shut up? Why don't anybody who wants me to sit down and shut up come down here and make me?
I can't hear you.
Hey everybody, a quick recap for those who are just joining in, and then I'll get to it. D Marble shot a laser over water and celebrated his victory. I ignored the video because it fit within the current model. He came to me and challenged me to debunk it. I shut down his laser test and gave him a little wink. He lost his mind over it because he thinks gay is icky. I thought that was hilarious and tried to walk away from the explosion all cool-like, only to be kicked in the balls by the over-the-pole scan. Marble and his band of lost boys danced the Pylean dance of joy over my imminent demise, and Daryl made one more video on me in an attempt to make me stay down. And that brings us to this. D Marble, self-proclaimed Superman to my Lex Luthor, decided to cosplay as a scientist in order to raise his charisma score and convince people that he knows what he's doing. And I have to say, he put this video together fairly well in terms of content. Anyone that doesn't understand the topics he's talking about might be convinced that he understands the topics he's talking about. That being said, let's look at what he says. He starts off by saying that he understands that refraction due to air temperature and density is a real thing.
As far as atmospheric refraction, atmospheric gradient, things like that, different variations in air density, those things, I don't say that those things don't exist. I've never said that those things don't occur. Those are scientific facts.
And defies anyone to prove he said otherwise.
I've never said that those things don't exist. And if you believe that I've said that those things don't exist, and if you've ever said that I've said that those things don't exist, I defy you. Go find the video where I said that atmospheric refraction, atmospheric gradient, and all that, light dispersion, beam divergence. Go to the video, timestamp it, come back to me and tell me when I said that, and I will send you $500.
Now, can I find somewhere where he has said it doesn't exist? No. But he has dismissed it out of hand, which makes it sound like he's saying it doesn't happen. But I have no problem saying you agree that refraction happens, Daryl. You just don't know how it works. You go on to say that you respect science.
Flat earthers do not discount science as a whole. We embrace science. We practice science. We respect science.
But then you say you don't support theories.
What we don't respect, what we don't appreciate is the theoretical science that's being passed off as fact. We don't appreciate theories being taught as truths.
With this statement, you've shown you don't have respect for science because you are not respecting the scientific definition of a theory. And you give gravity as an example of a theory, which is a further example of not respecting the science. You see, gravity is a fact. There is a force that acts on objects causing acceleration toward massive bodies. That force is in direct proportion to the masses of objects and is called gravity. There are theories as to the mechanism of gravity, but that's a separate thing from the fact of gravity, and if you practice science, studied science, and respected science, you would understand that.
Don't misunderstand. We don't discount all science. We discount the things that you have to believe in, the scientism.
I've been meaning to talk about this term, scientism, that flat earthers like to use. I find it interesting because it's an attempt to diminish science by equating it to religious faith. Let me repeat that. They are trying to diminish it by equating it to religious faith, which means that they are admitting that religious faith is of low value in the world of evidence. Yet many of these same flat earthers will tout a creator or magical properties as a way of filling in the many holes in their fantasy world. So, whenever someone says scientism, it just reaffirms that supernatural faith is bad evidence. Anyway, next he made an attempt at analyzing data. He took my air temperature and estimated my water temperature and compared it to his estimated air and water temperature. Estimated because he went to a website for his numbers in retrospect. And he came to the conclusion that since my air and water were so much different in temperature than his refraction should be less,
thus giving us the perfect conditions to create little to no atmospheric refraction due to temperature variation. The temperatures weren't at odds enough to actually create the atmosphere that would bend the laser sufficiently.
And this is where he shows he fundamentally doesn't understand how refraction works. But first off, I have to say that I'm not going to blame him fully for making this argument, because it wasn't his idea. He lifted this entire argument from a ranty flat earth video, this one here. Now, Daryl changed a couple of the numbers, but he's lifted the entire argument, even down to using the same punk-ass Microsoft Paint artwork. So the lack of substance to his position is not so much his fault as it is the fault of the person he copied his work from. Now, the video rant he made has only 1,000 views, while you bit his entire theme, Daryl, and you will get at least 10 times that. Maybe you should at least give him a little credit. Now, don't bother giving me credit for designing the thumbnail you used for the video. It's just nice to see that you appreciate my work. Anyway, the crux of your claim is rooted in refraction due to temperature. You say that since my water, not the air that it went through, had 4 times the temperature variance compared to your water, you should be able to claim 1/4 the refraction result.
The variation of his was 51.2, ours was 12.6. Now, if we divide 51.2 by 12.6, that gives us 4.06. So would it be fair for us to say that we should, under his conditions, had our laser beam been as close to the water, under our conditions of air and water temperature, we could expect roughly 25% of the atmospheric refraction based on the actual temperatures? Is that fair? Can we say that? I think so.
Now, that's not how refraction works, and I'll get to that in a moment, but let's assume you can use that kind of math. Well, my laser only traveled through my cold area for about 12 inches, while your laser traveled through your cold air for about 10 miles. I'll round it down for you. So even if your refraction level was 1/4 of mine, your laser was in the medium 52,800 times longer than mine. Whew. Did you feel that? That little flutter in your heart? That's the "you done fucked up now" feeling. Get used to it. You see, the amount of refraction isn't just about temperature. It's about atmospheric density, which is affected by temperature and is greater at sea level because of the weight of all the air above it. And refraction is affected by how long it is in the medium. Now, I'm going to make an admission here that I made a mistake in my laser demo video. A crucial science-based mistake that I noticed after I put the video up. But none of you were able to call me out on it because none of you know the science well enough. So, thanks for that. When I said my laser was refracted about 2 millimeters over 40 feet, I was wrong. It was actually refracted about 2 millimeters over 12 inches. You see, when the laser enters the denser medium, it's refracted. And when it exits, entering a less dense medium, it refracts back. I had projected the refraction like this, which was wrong. And you didn't know that. But if you had looked into it, you might have noticed that my refraction line should have been much steeper, like this, which meant the refraction level was a lot higher than I gave it. But that aside, let's look more at how atmospheric refraction works, since you admit it's real. You've admitted that when light passes through a denser medium, it refracts downward. Well, toward the denser medium, which tends to be downward in these situations. Now, I know my line isn't level. That's for a reason, and I'll get to it. Now, you've also said that you don't deny that there is an atmospheric gradient because it's a scientific fact.
As far as atmospheric refraction, atmospheric gradient, things like that, different variations in air density, those things, I don't say that those things don't exist. I've never said that those things don't occur. Those are scientific facts.
And an atmospheric gradient means as you get lower down, the air gets denser and denser. So as the light travels, it gets refracted more and more. And that's how you get a lot of refraction over distance. Now, what I just said follows directly from two scientific facts that you say you agree are real. You need to come to terms with why you won't accept the effects of it. Now, next you try to use something I said against me. If you have a laser that's close to the surface of the water for miles, it's going to refract a lot. You compared how close your laser was to the lake to how close my laser was to my water tray.
Well, Jerry, in addition to the minuscule air and water temperature variation from our test in comparison to yours, we now have to factor in that our laser was 10 times further away from the water than yours was during your demonstration, thus making it far less likely that the beam would be affected by atmospheric refraction.
Completely misunderstanding, because of my poor choice of words, that I was talking about how close to sea level a laser is, not how close to water in general. The amount of refraction at the top of a third-story building versus 10 feet up versus sea level, you see. So the distance above my tray isn't comparable. But even if it were, you chose to ignore the part I said about for miles. Close to the surface of the water for miles? And if you had factored that in, you would be comparing 10 miles to 12 inches. You then go into what it would look like when a laser is going straight toward a camera. But that's not a factor because I'm not claiming that the laser wasn't hitting the camera, just that the beam had spread out. You used a tight laser beam to say that if a beam is obstructed at all, it is completely blocked. But at 10 miles away, you weren't looking at a tight beam. You were looking at a wide beam. How do I know this? Well, first, the manufacturer's specs for the laser says that it would spread out. And in your original video, there's a moment when you can see the laser in the P900 viewer. You can see it in the camera you're going live with. And you say you can see it with your naked eye.
We're seeing right now, people, 10 miles away. Look, you can see the laser. Dude, I can see the laser with my naked eye right now. Everybody can see it off in the distance. I'm not even looking into the camera right now. We can all see the laser together right now, 10 miles away, dude.
That tells me, that tells you, that the beam has spread out enough to hit you and your two cameras. Next, you try to show that even a light that is diverging won't go over bulging water, a phrase you have never heard me say, by the way, and something I have never claimed. But you put a message on the screen here that is very important. Photons of light travel in a straight path, Jerry. You know that. This looks a lot like you're saying that refraction doesn't exist.
Go to the video, timestamp it, come back to me and tell me when I said that, and I will send you $500.
16 minutes, 3 seconds. That's $500. GreaterSapien at Gmail. PayPal, please. Nah, come on. You know I could use the money.
Hello, darkness, my old friend.
Next, you lifted Ranty's clip art, or you had him do this for you, to make a mocking claim that I was incorrect when I said the beam would essentially be a bright half circle at the surface of the water. Culminating with this.
What's this, Jerry? A circle. Yay! Good job, Jerry. Yeah, that wasn't a half circle.
Yeah, that right there is not a half circle, but let me show you something. You see that circle of light right there? That's a little more than a half of a circular flashlight beam shining on the camera. Now, it looks like a full circle, because of the intensity. But if I take the camera up to it, you can see that the beam is obscured by a book. Now, there's no denying that we saw a full circle, but the bottom half of the circle was where we know the book to be. That's just how light works when it is bright. But if we filter out the intensity by squinting our eyes or adjusting the levels on the camera, hey look, half circle above the book. Let's go back to your laser. Look at that water line. That circle seems to be right at the water line. No, actually, it's straddling the water line. Half of it is above and half of it is below. How does that work? How is your laser shining through the water? Now, I put it to you that it is not shining through the water, that it, like my flashlight, is partially obscured by the horizon, and only its intensity that makes it look like a circle. Now, if there was a way of lowering the intensity of that beam, we could tell if I'm correct. Well, lucky for us, these lasers aren't perfect, and if the laser or the camera moves, you sometimes end up in a less intense spot of the beam. Like... boom. There you have it. A half circle, broadcasting from the horizon. Whew. Feel it again? The rest of your video is you talking about your experience with lasers, who cares, and you claim a couple more times that they don't bend, which sounds a lot like denying refraction again. And you have this thing here about water bulging, with this terrible graphic saying,
in addition to water bulging, which goes against what everyone experiences in reality, you're also trying to say that laser beams will also curve over the bulging water on this imaginary globe.
And the funny thing is, you have never heard or read anywhere that I've said that there is bulging water like this. I may have mentioned the tides bulging, but never spoken of water bulging like this due to the globe. If you find it anywhere that I have said it, I'll give you your $500 back. You see, no one says this is how the Earth is set up. You have never heard me claim that a laser would go over a bulge and back down to the viewer. That claim is only in your head. Here's what I'm saying. Let me use this graphic that you mocked earlier. Now, there's no bulging water. This is just the water that is gravitationally level on the surface of the Earth. The laser is not like this. It's like this, projected straight out. Now, it's not a perfect beam, and thus it gets wider over distance. In other words, the bottom edge of the beam isn't going out level, it's going down at an angle. Because of that, it goes into a slightly denser medium and refracts like my earlier graphic. It continues to refract more as it enters more and more dense atmosphere. But that beam was never going up. The bottom edge was always traveling downward. This is down. This is down. There is no up over a bulge, only down into denser air. You then take up the mantle of the bellwether, the sheep that the other sheep follow, by giving them a question to ask me, and I would reply to you and to all of them, what part of refraction don't you understand? But we all know that the answer is all of it. You wrap things up nicely, and I mean that. I think summary statements help clarify a message. The problem is, the things you claim don't hold up under scrutiny, which I have clearly shown here. So while your conclusion is well stated, it is meaningless, and only holds sway with those that don't know any better. You say that I need to show evidence of curvature to prove the globe. Now, putting aside all of the evidence that you choose to ignore, you seem to be under the mistaken impression that I'm here to prove the globe. No. I'm here to point out the pervasive ignorance and poor thinking that is at the core of fantasy leagues like yours. I'm calling out the bias and the bigotry and the paranoia and the fear that tries to pass itself off as common sense. Because on the internet, ignorance can easily disguise itself as knowledge. All it has to do is put on a lab coat and glasses.
That's my job. That's what I do. I don't lose. there no one on this planet to even challenge me?
Maybe you came by to congratulate me on last night's victory.
Wait a minute. Did you guys see this?
That's my job! That's what I do! I don't lose!
Yeah. We always knew you wanted to be me when you grew up.
I win! I win! Is there no one on this planet to even challenge me?
Maybe you came by to congratulate me on last night's victory.